Good afternoon, ladies and gentlemen. My name is Stan Forrester. This is being recorded for Miami Dade on June 6, 2023. This is the physics problem solving method. This is part 2. We're going to do an example. So an example, Carla likes to take her dog Bowser on a run in the local dog park, where she can let him off the leash. She jogs at 2 meters per second and takes 15 minutes to reach her destination, which is the duck pond. Bowser, being off his leash, runs at full speed, 6 meters per second, back and forth between Carla and the duck pond. Specifically, Bowser reverses his direction upon reaching either destination and continues to do so till Carla reaches the duck pond. What total distance d does Bowser traverse in the time it takes Carla to reach the duck pond? Okay. Key idea. Problem addresses motion under constant acceleration. In other words, acceleration equals 0 is a constant. It is a very special constant, but it is constant acceleration. Therefore, your key idea is likely kinematics. Okay, your stock of data. Okay, so we're going to cross out, take our problem statement, we're going to cross out a bunch of stuff here. I'm going to highlight some things. 2 meters per second, that's Carla's speed, velocity. Okay, one-dimensional velocity. 15 minutes is the time. We're going to go ahead and convert that to 900 seconds because none of our formulas or quantities are really measured in meters per minute or anything like that. So we're going to convert that to a standard SI unit. The dog's velocity or speed is 6 meters per second. And we identify in green what our unknown is. Okay, this is the total distance d. And I went ahead and I threw in the acceleration equals to 0. Because I think that might be useful. Okay, IE equation. Of the 5 basic kinematics equations, only 2 of them possess displacement. Okay, so the displacement is 1/2 acceleration times time squared, plus the speed in that particular direction times time, or final velocity squared minus initial velocity squared equals 2 times the acceleration times the displacement. We'll note that the acceleration is 0. So in this particular case, the acceleration is 0 is going to make the displacement vanish on the right-hand side. This one's not usable. Okay, so we're only left with one equation. We're further going to be able to simplify this by noting that the acceleration is 0, and so the first term of the only remaining equation actually vanishes. Okay, we're going to substitute in some numerical data. We've let the time equal 900 seconds, and the velocity equals 6.00 meters per second. So we're going to plug those in, and we come up with our displacement is 5,400 meters. Okay, we're still at the end of our substitute step, but we're going to take a look at our significant digits and our units. One, it's a displacement, so yes, it is in meters. Okay, the value 900 seconds suggests that we round our answer to one significant digit. That said, our numerical inputs were given to 3 significant digits. 2.00 meters per second, 15.0, and 6.00 meters per second. Our solution only appears to have 2 significant digits, but the 0 after the 4 is actually significant, even though we have trouble letting people know that. But let's go ahead and assign uncertainty to our result. It's 1/2 the least significant digit. The least significant digit is in the tens column. Half of that would be 5. And so our uncertainty is going to become plus or minus 5 meters. Okay. Our sanity check. What would happen to the distance traveled by the dog Bowser if his speed or the time spent running were to increase? We look at this. Our intuition says that the distance traveled would increase. Does our algebraic solution support this intuition? Yes. Yeah, we're multiplying on the right-hand side. We're multiplying the speed times the time. Either one of those increases. The left-hand side is also going to increase. Okay. We might also reason that when running at 3 times the speed of the human runner, the dog is going to cover 3 times the distance in the same time. The distance covered by the human runner is 2 meters per second times 900 seconds. 3 times that is going to be 5,400